channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your data warehouse and data mining classes, and this is your class 7. And first of all, we had done your 6 classes before, where we had covered up the unit 1 and unit 2, and then we had covered up the unit 3 as well in the last classes. So now we're going to start with unit 4, which is your the classification and clustering here. In the classification and clustering, this is your class 7 here. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe to our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In the terms of it, if I'm talking about here, so now we'll go ahead with the decision that what we have to discuss here, and that is we'll start with the concept description in this class. In that I will just tell you a short note about it, that the concept description, it is a basic form of the descriptive mining and describes a set of tasks that is relevant data in a concise and a summative manner, and which presents interesting general properties of the data as well. In the same cases, talking about the another thing that we'll discuss about is your characterizations, and that is it summarizes and describes the collections of data that call the target class as well. And the comparison that we'll discuss about it, that it summarizes and distinguishes the one collection of data that call the target class for the other collection of the data that call the contrasting classes as well. Talking about the data generalization, which is it is a process that summarizes the data by replacing the relatively low level value with a high level concept as well. In the case of the analytical characterizations, and it is a statistical method for pre-processing data to filter out irrelevant attributes or the rank of the relevant attribute, and the incorporations of pre-processing step into a class characterization or a comparison is called analytical characterization, that we'll discuss in a detail as well. In the same case, talking about the implementation of the concept of the characterization, that even though we'll discuss here in a detail, which is your data cube, that is your OLAP based approach, and the second is your attribute oriented induction approach. And in the same case, I'll talk about the techniques of the attribute oriented induction approach, which is your data focusing, data generalization by attribute removal, the count and aggregate value accumulation, attribute generalization control, and generalization data visual control, that we have to cover up here. So let's go ahead to discuss about it in detail, and the implementations of the concept comparison also that we'll discuss here, which is your the data collection, and that is your dimensions, relevance analysis, and the presentations of the derived comparison also, that what we have to discuss here. So let's go ahead to discuss and start in a detail here, that is your write a short note on a concept description, and what do you understand by the term data characterization, and the contrast that context to the concept description here of 5 marks. So this is your concept description. In the concept description, talking about it, the concept descriptions is a descriptive kind of data mining, and it refers to a collections of data such as affluent that buyers and that the graduate student, etc. It provides a description for the characterizations and comparisons of the data, and it is something that called the class description, and when the concept that to be described refer to a class of object as well. And these descriptions that can be derived with the help of a data characterization, and the data characterization is the summarizations of the general characteristics or feature of a target class of a data, and the data that is related to a particular user defined class that is generally retrieved by a data query, and that the output of the data characterization that can be presented in a various forms like bar charts, curves, pie charts, and light graphs, etc. We are talking about the characterization, which is where the characterization that provides a concise summarizations of a given collection of data, while the concept or the class comparison that provide the description comparing the two or more collections of data as well. Now we'll talk about the another one, which is the difference between concept description in large database with OLAP. So let's go ahead. Concept descriptions in large database with OLAP. Well, talking about this, that is the OLAP tools and the concept description in the large data database as well. So in the OLAP tools, that the data warehouse and the OLAP tools that are based on the multidimensional data model that views the data in the form of the data cube, and that consisting of the attribute and measures, and that you confine the dimensions to the non-numeric data as well. In the concept of description in the large database, we are here the database attribute that can be of various types, and including the numeric, non-numeric, spatial, and text or image as well. The second one we have is that OLAP represent a simplified model for the data analysis because of its restrictions on the possible dimensions and the measure types, and where the concept descriptions in the large databases which we have is your with aggregation, the concept descriptions in databases that can handle the complex data types of the attribute as well. The third one, that in the OLAP tools, that the OLAP is a data warehouses is a purely user controlled process, and the selections of the dimension and the applications of OLAP operations such as drill down, roll up, slicing, and dicing, and of course are directed and controlled by the user. And in OLAP, that the user needs to specify a long sequence of OLAP operation as well. But in the concept descriptions in the large databases here, that the concept description in the data mining that requires a more automated process that help the user to determine which attribute that should be included in the analysis, and the degree to which that the given data that should be generalized in order to produce an interesting that summarizations of the data as well. Now we'll go ahead with the detailed that what we have to discuss about it, which is your define the terms define the terms data generalization and analytical characteristics, that the characterizations with an example. So let's go ahead with the data generalization here. An analytical characterization. So in data generalization and analytical characterizations here, with this reference towards it, that the data generalization that summarizes data by replacing the relatively low level values such as the numeric value for the attribute age, and with a high level concept such as young, middle age, and senior as well. Hence, it is a process that abstracts a large set of task relevant to data in a database from a relatively low conceptual level to the high conceptual level, and following other two approaches for the efficient and a flexible generalization of a large data set. So the two approaches for the generalization we have, for the generalization is OLAP approach, and the second we have, that is attribute oriented induction. That is in the OLAP approach here, that the data cube technology that can be considered as a data warehouse based that a pre-computations oriented materialized view approach, and it performs an offline aggregation before an OLAP or a data mining query is submitted for processing as well. For the attribute oriented induction approach here, that it is a relational database query that oriented, and the generalization based online data analysis technique, and an attribute oriented induction where the task relevant data is collected using a relational database query, and then generalization is performed based on the examination of the number of the distinct values of each attribute in the relevant set of data, and the generalization is performed by attribute removal By merging the identical generalization that generalized tuples and accumulating their respective counts, perform aggregation, reducing the size of the generalized data set, and interactive presentations with the user as well. Let's go ahead to discuss about it, which is your basic principles of attribute-oriented induction approach. Basic principle of attribute-oriented induction approach. In this, that basic principles of attribute-oriented induction approach here, that is the basic principle that we'll talk about it. And here the first heading we have here is that is in the reference towards the approach, the principles of attribute-oriented induction approach here. The first we have is your data focusing. In the term of the data focusing, if I'm talking about here, that the data should be the task related, including the dimensions and the results in the initial relation. The second we have here is your that is attribute removal. In the attribute removal, where we have to select the set of the relevant attribute or remove attribute A if there is a large set of distinct values for A, but there is no generalization operator on A, and the A is higher level concepts that are expressed in the terms of the other attribute as well. The third we have is your that is attribute generalization. In the attribute generalization here, if there is a large set of the distinct values for A and there exists a set of generalization operators on A, then select an operator and generalizes. And an analytical characterization that we talk about it, that the analytical we'll talk about the relevances as well, so we'll talk about in a detail within other heading, that is your analytical characterization. In the analytical characterization, talking about it, it is a statistical method for pre-processing data to filter out irrelevant attribute or the rank of the relevant attribute as well. The measure of the attribute relevance analysis that can be used to identify irrelevant attribute and that can be excluded from the concept description process. And the incorporation of this pre-processing that step into the class characterizations comparison is referred to as the analytical characterization as well. Talking about with this, that is the reason for attribute relevance that we'll talk about it. Reasons for attribute relevance analysis. So in the reasons for the attribute relevance analysis here, the first reason is to determine which dimension that should be included. The second is to achieve the high level of generalization, and the third is to reduce the number of attributes which help us to understand the pattern easily as well. In the same case, that the general idea behind the attribute relevance analysis is to compute the sum measure that is used to quantify the relevance of the attribute with respect to a given class or concept. Such measure include information that gain uncertainty and correlation coefficient as well. Now we'll talk about with the detail that is to discuss the mining class comparison or how to discriminate between the different classes. So mining class comparison, we'll talk about it. In the mining class comparisons here, that the class determinations or comparison means that the description that distinguishes a target class from its contrasting the classes, and for example that the three classes, which is your person, address and items, that are not comparable as well, and however the sales in the last 3 years are comparable classes. We have the attribute of the generalization for the class characterization that can be modified so that the generalization is performed synchronously and among all the classes compared. For example, we want to compare the data of XYZ company for the sales of first the sales, that is your 2002 and 2003, and then compare these two classes as well. Then we consider the dimensions, location, and the abstractions of the city, state, or a country level. We need to generalize this to either the city level or the state level, and the type of the comparison. So the type of the comparison that we'll talk about it is more useful than the comparing it that says, and of course that the sales at the China in 2002 with the sales of in India, that is in 2003. The general procedure for the class comparison that consists of the following types, and the first type we have is the data collection. The data collection, that the collection of relevant data by a query processing and a partitioning into the target class and one of the more a set of contrasting class as well. The second we have here is your another one, which is your dimension relevance analysis. The dimension relevance analysis, that if there are many dimensions and there is a desire to compare it analytically, and then dimension relevance analysis that should be performed these dimensions, and only the highly relevant dimensions are included for comparison. And that is the another one. We have your third one, that is your presentation of the derived comparison. Of the derived comparison here, that the final result of the class comparison that can be visualized in the form of the tables, graphs, and the rules. This presentation includes the contrasting measure that reflects the comparison between the target and contrasting classes as well. So now we'll go ahead with the discussion that we have to discuss about, like the another question, that is to discuss why analytical characterization that and attribute relevance analysis are needed. क्यों इनकी ज़रूरत पड़ती है analytical characterization or attribute relevance analysis की. They had asked you about 10 marks this question, and that is the another question in the terms of it that they had asked you. Discuss the reasons why we perform the attribute relevance analysis. This is also 5 marks, and another question with reference towards this only, and that is to discuss why analytical characterization and attribute relevance analysis are needed and how these can be performed. That has been asked of 10 marks. So according to the question, what they demanded, according to the question, the marks of the question has been presented. So we'll go ahead with the discussion of analytical characterization, even though that we had discussed about it, and what we have even gone ahead as well. So let's discuss moreover related to this. That is, the first we have is an analytical characterization. In this, an analytical characterization, that is that it is a statistical method for preprocessing the data to filter out the relevant attribute or the rank of the relevant attribute. The measure of the attribute relevance is analysis that can be used to identify the irrelevant attribute that can be excluded from the concept description process, and the incorporation of this pre-processing step into the class characterizations or the comparison is referred to as an analytical characterization as well. Talking about the need of attribute relevance analysis, what were the needs that will deal with it. So first need we have is which dimension that should be included, and the second need is how is the high level of generalization take place, and the third is that to reduce the number of attribute and easy to understand the pattern as well. That the general idea that behind the attribute relevance analysis is to compute some measure that is used to quantify the relevance of an attribute with respect to the given class or the concept. Such measures include the information gain, uncertainty, and a correlation coefficient. Attribute relevance analysis for the concept description is to be as performs as the first we have, as I talk about it, that is your the data collection, and the collect data for both the target class and the contrasting class by the query processing. The second we have is your preliminary relevance analysis using the conservative AOI, and in that same case this steps that identify, talking about the another one which will go ahead. which is the attribute relevance. So in the attribute relevance, that the first we have is your data collection. Data relevance. In this data relevance, that to collect the data that for both the target class and the contrasting class by the query processing. Talking about the second one which we have here is your, that is preliminary relevance analysis using conservative AOI. In this steps identifies a set of dimensions and attribute on which the selected relevance measure is to be applied. AOI that can be used to perform the preliminary analysis on the data by removing the attribute having a large number of distinct values. To be the conservative, the AOI performed here that should be employed the attribute generalization threshold that are the set reasonable large so as to allow more attribute to be considered in the further relevance analysis by the selected measure as well. Talking about the another one, we will talk about the third one, which is your that is your remove. In remove, that this steps removes irrelevant and a weakly relevant attribute using the selected relevance analysis measure. Now talking about the fourth one, which is we have is to generate the concept description using AOI. So in this, that perform AOI using a less conservative set of attribute generalization threshold if the descriptive mining task is class characterization and only the initial target class working relation is included here. So if the description mining task is a class comparison, both the initial target class working relation and the initial contrasting class working relation that are included here only. Now I'll talk about with another one, which is the another question. With the help of a suitable example, you have to explain the data discrimination. So in the data discrimination, talking about in the term of the data discrimination, which has been asked for 5 marks, data discrimination produces a discriminant rules which are comparison of the general features of the object between the two classes that is referred to as a target class and the contrasting class. It is a comparison of the general feature of targeting the class data object with the general features of the object from one or a set of contrasting class. The user that can specify the target and contrasting classes and the technique that is used for the data discrimination and very similar to the technique that is used for the data characterization, with the exception that the data discrimination results include the comparative measures. For example, that the user may like to compare the general feature of the software product whose sales increases by 10% in the last year and with those whose sales decrease by about 30% in the same duration as well. Now we talk about some of the things that is in the detail as well, and in the same case that I will go ahead as well in the terms of statistical measure, that the two descriptive statistical measures are used. That is, the first is to measuring the central tendency and the other is to measuring the dispersion of the data as well. They're talking about the another one, which is the measuring of the central tendency, and the formula for that will be finding out as mean, median, and of course for the mode as well. And when n is odd, then n plus 1 by 2 value, and of course for the median, which is n by 2 at a value plus n by 2 or plus 1 at a value by 2. And for the mode, that the most common occurring observation in the group of the values, that what we have to talk about it. Here we'll have to deal with the measuring of the dispersions of the data. We'll talk about the range, quartile, and variances, as well as standard deviations. In that range, that the difference between the largest value and the smallest value, you find it out the range here. In the quartile, the most common percentile other than the medium that are called as quantile, and you can see that that 25th percentile we have to find it out for that as well. And that is in the same cases we'll be having a formula for the finding out the variances as well, the data standard deviations as well. Talking about the graph for the statistical class description, the graph that are used to display the data, it summarizes and distribution, that the types of the graphs we have, the histograph and the quantile plot, quantile plot and scatter plot as well, and that is your the Loises curve as well. And in this, the histogram, that is the partition that the data distributions into the disjoint subset or a bucket, and each bucket is represented by a rectangle, and which shows the frequency of the values as well. In the quantile plot, it displays all the data for a given attribute, and then it plots a quantile information. In the quantile plot here, it graphs that the quantile of one univariate, and that is the distribution against the corresponding quantile of the others. And the scatter plot, that it is used when there is a relationship between the two numerical attributes, and each pair of the values is treated as the pair of the coordinates and plotted as points in the plane as well. The Loises curve, it adds a smooth curve to a scatter plot as well. Talking about the statistical based algorithm, where the two types of statistical based algorithm we have, the regression and the Bayesian classification. Now we'll go ahead with the detailed of all each and everything that what we had told about it. Let's go ahead here. Now we'll talk about it. That is the statistical measures in the large database. So the statistical measures in the large database here, there's just of 5 marks, and that is the relational database system that provides a 5 built-in aggregate function, which is your count, sum, average, max, min here. And these aggregate function that can be used as basic measures in the two descriptive mining of multidimensional data, and where the two descriptive statistical measure, that is the measures of the central tendency and the measures of the data dispersion, that can be used efficiently in the large multidimensional database as well. Talking about the first one, that what we have here is your measure of central tendency. So in this, the measure of the central tendency here, that the measure of the central tendency that include mean, median, mode, and a mid-range as well. So in this, the first part of measure of central tendency we have. So here, that is your mean. So in the mean here, that the arithmetic average is computed simply by, that is adding together all the values and the dividing by the number of the values, and it uses the information from every single value, where we'll let x1, x2 until x delta here, and that is for the xn, and that be the set of the n values or the observation like salary. The mean of the set of the values that has been represented here is in the form of x bar equals to, that is your n xi, where xi equals to 1 upon n equals to x1 plus x2 plus x3 till xn upon n here. So this corresponds to the built-in the aggregate function, where the average, that is your average provided in a relational database system, and in most data cubes, that sum and count that are saved in the pre-computation, so that the derivations of the average in a straight forward, and we can say that the average equals to sum upon count. So average equals to sum upon count here as well. Talking about the second one, which is here, that is the another one as well, that is your median. In the median case, there are the two methods for computing the method, that is the median, that is depending on the distributions of values, and if x1 x2 till xn are arranged in ascending order and n is odd, then the median would be here is as to be as follows, that is your n plus 1, which is the nth upon 2. This is the value we'll find out for the median here. And for example, if for example, we have a question like 1 4, we'll just write it on 1 4 6 7 12 14 and 18. So in this, we'll just count it n plus 1, so we'll solve it out. 1 2 3 4 5 6 7 7, that is means the median is odd, so we'll put the value here, which is in place of 7 plus 1 upon 2, 7 plus 1, which is 8 upon 2, and that we'll get fourth. So the fourth term will be having a median, that is 1 2 3, and this is 4, so the 7 is your median here in this case. So that is the another one we'll talk about when n is even. अब मान लो n even है, ये तो odd के case में हो गया. If n is even, then what will we do here? So in that case, when n is even, then median, the formula we have is, for n is even, this is for odd, so then we have the formula n by 2th value plus n by 2th plus 1th value and by 2. So here for the n by 2th, so let's have a same question for this as well. And taking another question, this is your 1 4 6 7 8, then 12 14, and of course 16 here. So here 1 2 3 4 5 6 7 8, 8 here. So in this, that is this 8 by 2 plus 8 by 2 plus 1, 8 by 2 plus 1. So here 8 by 2 is your, of course, that will be concluded here, and that will be the another one. This is will be counted on 8 by 2. This is your 4, and this is 8 by 2, that is your 9 by 2. So 4 and plus 9 by 2. So this has been cancelled. Let's take an LCM. 4 2s are 8. So that is 8, and that is 9. So plus 9 upon, that is your 2 here. And then we'll solve it out. So then we'll get it out as your, that is 8 plus 9, that is 17 by 2. And 17 by 2, then we'll cancel it out. This is 8.5, and that will be the right answer. And the median is neither a distributive measure and not an algebraic measure, so it is a holistic measure. And although it is not easy to compute that the exact median value in a large database, and an approximate median that can be efficiently computed as well. Talking about the another one, which is the mean, median, and now we'll talk about the mode here. So here with the same concept, we'll be having a mode. In the mode here, that is, it is the most common value in a group of values distribution, and that the distribution that can be unimodal, a bimodal, and a multimodal. And if the data is categorical measures on the nominal scale, they only that the mode that can be calculated, and the mode that can be also calculated with an ordinal and a higher data, but it is not appropriate as well. So for that, the first we have is the measure of dispersion data. Measuring the dispersion of data. and that is in the terms of it that the degree to which the numerical data that tend to spread is called the dispersions or the variance of the data. And the most common measures of the data dispersions are range, interquartile range, and the standard deviation as well. Let's go ahead with the talking about the another one, which is your range here in terms of it. The first we have is your range. In the range here, that the range is defined as the difference between the largest value and the smallest value in the set of data, as I told you about. So that range equals to XL minus XS, the larger value minus a smaller value here. In the same case, talking about it, where for example, like consider the following data. I will just let you the for the following data here. That is the data we have is your 4, 8, 1, 6, 6, 2, 9, 3, 6, 9. In this, the largest value of XL is, as you can see here, that the largest value is 9 and the smallest value is 1. So we'll take as 9 and 1. So we'll put the value here, that is XL minus XS, so that is 9 minus 1, and then we'll get 8 here. Now we'll talk about the another one, which is the second one, and that is your the quartile. In the terms of the quartile here, that the most common percentile, other than that the median, that the quartile, and the first quartile that is denoted by Q1, and the 25th percentile is the 25th percentile, and third quartile is denoted by the Q3 and is the 75th percentile, and the quartile that including the median and give some indications of the center, spread, and a shape of the distribution. The distance between the first and the third quartile is a simple measure of spread that gives the range that covered by the middle half of the data, and this is called the interquartile range of an area that is defined here, and that is named as IQR is equals to Q3 minus Q1. So this is your interquartile range here. So in the same case, that the semi-interquartile range, that is SIR, is defined as the difference of the first and the third quartile between the two, and the first quartile is the 25th percentile and the third quartile is of 75th percentile. So the S square will have here in the same case, that is SIR equals to Q3 minus Q1 upon 2. And now we'll talk about the third one, which is the standard deviation. In the term of the standard deviations here, that when the deviate values that are squared in variance and their unit of measure is squared as well. For example, if the people weight are measured in the kilometers, and then the variance of the weight that would be expressed in the kg square and the squared kilometers. So since that the squared units of the measured often allows that the knowledge with the square root of the variance is called instead, and that the standard deviations that the square root of the variance as well. So now talk about another one, which is your fourth one, which is comes under the variance. In this, it is defined as an average of the square deviation, where x1, x2 till the xn are the observation, and the variance of that we know can say that variance, that is square equals to 1 upon n, and I equals to 1 minus x bar, and that is standard deviation. If I'm talking about here, that is your standard deviation equals to under root variance. Okay, so this is what it was, and next I will go ahead with another one, and that is here, that is the given the following set of values of 1, 3, 9, 15 and 20, and that to determine the jackknife estimate and both the mean and the standard deviations of the mean, that what we have to find out, which has been asked of 5 marks as well, and even though which is also an important one because this has been a very important question. So let's go ahead with the the solution, that what we have to do here. So here we'll go ahead here as well. So let's go ahead with the question. Given the following set of values, 1, 3, 9, and 20. Determine Jackknife estimate for both the mean, standard deviation of the mean. So here we'll solve it out for this. The solution we'll get here, which is your the n here is n equals to 5, x I equals to, which is represented as 1, 3, 9, 15, and of course 20, and x1 is your 1, x2 is your 3, and x3 is 9, so on. X4 is 15, and x5 is 20. So we'll put the value for that because we have to find it out the mean here. Mean equals to x1 plus x2 plus x3 plus x4 plus x5 upon the number of terms that we have is your 5. So when we solve it out, we'll put the value 1 plus 3 plus 9 plus that is your 15 plus 20. So here in the same case upon 5, and we will talk about it. 20 plus 30, 35, 35 and 35, 36, 37, 38, and 39. 39 plus 9, that 39 plus 9, that is your talking about it, and that is your 39 and plus 10, that is your 48. So 48 by 5. So we'll solve it out. We'll get it 9.6. Now we'll talk about that for by ignoring the x1. If we are ignoring the x1, of course, so what we will be getting is in the same pattern that what we have to follow, and I will have to ignore x1, then we will have to ignore x2, then we'll have to ignore x3, and simultaneously we'll ignore x5 as well. So in the same cases we will be have to find it out each and everything. So by ignoring x1, so here it will ignore x1, so that means x2 plus x3 plus x4 plus x5 upon 1, 2, 3, 4. So the quantity is 4, so we'll put the value here, which is your 3 plus 9 plus 15 plus 20, and by 4 when we solve it out we'll get 11.7. For the another one, we'll ignoring x2. When we ignore x2, we include x1, so x3, x4, x5 upon 4. We put the value 1 plus 9 plus 15 plus 20 upon 4. So that is 20, 30, 35, 35 and 10, that is 45. 45 by 4, and then we'll solve it out. We'll get it. That is your, this is 11.75. This is 11.25. Now ignoring x3, which is equals to x1 plus x2 plus x4 plus x5. So when ignoring x3, it means we'll ignore 9, 1 plus 3 plus 15 plus 20 upon 4, and when we solve it out further, that is 20 plus 35, and 35 plus 4, that is 39. So 39 upon 4. In the same case for the 39 upon 4, that will go ahead and that will find it out 9.75. Now we'll be ignoring x4, so that is x1 plus x2 plus x3 plus x5 upon 4. We'll put the value here, that is your 1 plus 3 plus 9 plus 20 upon 4. So here that is 20 plus 30 and 33, so that is 33 upon 4. And that same cases we'll be finding out 8.25. Now we will be ignoring 5, and that is your x1 plus x2 plus x3 plus x4 upon 4, which is equals to 1 plus 3 plus 9 plus 15 upon 4. So in the same cases, talking about 9 plus 8, 1, 10, and 10 plus 20, 25, 28 upon 4. So in the terms of 28 upon 4, when we'll solve it out this, then we'll get 4 1s are 4, 4 7s are 28. So we'll get 7 here. Now further we'll go ahead and we had ignored everything, so everyone by individually. So for x1 we ignore that, let be theta 1, this will be theta 2, this will be the theta 3, and this is theta 4, and this will be the theta 5 here. So let's solve it out for that, and we'll be finding out the mean of all by divided by 5, and we'll find out what value will we get here. So here we'll go ahead by ignoring this, and then theta bar equals to theta 1 plus theta 2 plus theta 3 and plus theta 4 theta 5. So in the same case upon 5, the number of quantities is 5, so that is 11.75 plus theta 1 has been finded out, 11.25, then 9.75, then plus 8.25 plus 7 upon that is your 5, and we'll solve it out in a huge, so they'll get 9.6 here, and that is your theta bar. And for the jackknife estimate for a mean is to be as given here, that I will just write it on the formula as well. Jackknife estimate for mean is given as, that is your n x bar minus n minus 1 theta bar. So n here, that is your 5, x bar is 9.6 minus 4, and the n minus 1, that is 5 minus 1, that is 4, and that is your 9.6, which we had find it out here. And when we solve it out, this is your will get is your 9.6 here. And the other one is the standard deviation. We'll have to find it out, so let's go ahead for the one. Standard deviation. In the standard deviation, which we'll get here, that is your x minus x bar square upon, that is your n. So in the same case, we'll get it sigma 1 upon 5 1 minus 9.6 whole square plus 3 minus 9.6 square plus 9 minus 9.6 square plus 15 minus 9.6 square plus 20 minus 9.6 square. So here we'll put the value and we'll find it out. So that is equals to under root 1 upon 5 multiply 255.2, and we'll get it, that is your 51.01, and we'll get 7.144 here as well. By ignoring x1 here, also we'll ignore the x1 here, and then we'll find it out for the value as well. So let's go ahead for the solution. By ignoring x1, sigma 1 equals to 1 upon 4 3 minus 9.6 square plus 9 minus 9.6 square plus 15 minus 9.6 square plus 20 minus 9.6 square, and then we have it, and that is just sigma 1 equals to 1 upon 4 multiply 181.24, and we'll find it out the root here as well. We'll get 45.31, which is equals to 6.73. Now we'll ignoring x2. So for ignoring x2, which is sigma 2 here, is equals to 1 upon 4 1 minus 9.6 square plus 9 minus 9.6 square plus 15 minus 9.6 square plus 20 minus 9.6 square then we'll get sigma 2 equals to 1 upon 4 into 211.64, which is equals to 52.91 equals to 7.27. Now we'll solve it out for the another one, and that is your for by ignoring the x2, that we will be ignoring the x3 as well. Ignoring x3, that is equals to 1 upon 4, 1 minus, that is 9.6 square, plus 3 minus 9.6 square, plus 15 minus 9.6 square, and plus 20 minus 9.6 square. Sigma 3 equals to 1 upon 4 into 254.84, which is equals to under root 63.71, which is equals to 7.98. Now we'll go ahead for ignoring x4. In ignoring x4, we'll be having 1 upon 4, that is your 1 minus 9.6 square, plus 3 minus 9.6 square, plus 9 minus 9.6 square, then 20 minus 9.6 square, and then we'll have sigma 4 equals to 1 upon into 226.04, which is 56.51, which is equals to 7.51 here as well. Now by ignoring x5 here, that one we have to solve it out here as well. By ignoring x5, the sigma 5 equals to 1 upon 4 into 147, and that is your that is equals to 147.04 under root, that is equals to 36.76, which is equals to 6.06 here. For the sigma bar that they will be finding out here, that is your sigma 1 plus sigma 2 plus sigma 3 plus sigma 4 and plus sigma 5, and that is upon 5 as well, and we will sum it out each. 6.73 plus 7.27 plus 7.98 plus 7.51 plus 6.06 upon 5 here. So when we'll solve it out here, sigma bar, that is supposed to 7.11 here. So now for the Jackknife estimate for the standard deviation is to be as follows. That is equals to n sigma minus n minus 1 sigma bar. So we're putting the value 5, 7.144, 5 minus 1, 7.11, which is equals to 35.72 minus 28.44, which is equals to 7.28. So that's what we find it out here. So this is a long question, but that is you have to solve it out when they had asked you about it. Let's go ahead with another one where that is that what we have to discuss each and everything in a form matter, and that is to discuss the sum of the graph that is used for the display of the data that summarizes and the distributions as well. And in the same cases, let's talk about it, and that is to discuss some graph displays of basic statistical class description. So in this, the graphs of the displays of the data summarizes and distributions that are histograms, quantile plots and QQ plots and scatter plots, and of course the lysis curves as well. So let's go ahead to discuss about in a detail. The first we have is your histograms. In the histograph, it is a graphical method for summarizing the distributions of a given attribute, and a histograph for an attribute A that partitions the data distributions of A into a disjoint subset or a bucket. Each bucket is represented by a rectangular whose height is equals to the count and the relative frequency of the values of the bucket. Let's consider the following for the sales of the product, and we will talk about the computer, televisions, and the CD player. So that will be represented by that is in the form of the histograph. So that has been represented in the following way. This is for computer, this is for television, and this is for, of course, the CD player. That totally depends upon 1, 2, 3, 4. So here the second one we have here is your quantile plot. In the sum of the quantile plot, it is simple and effective way to have a look on the universe that univate the data distribution, and all of the data that are given attribute are displayed, and then it plots the quantitative quantile information where x1, x2, x3 till xn be the data that is sorted in the increasing order, and each observation that is paired with a percentage f, and which indicates approximately 100 FY% and the data that are equals to the value of xi, and we will talk about it, and that has been represented by the dotted slots as well. Now we'll talk about the third one, which is named as that is quantile plot. In the quantile plot here that has been represented, and that is a quantile plot or a QQ plot, that a graph of the quantile of one n variable distribution that is again the corresponding quantile of the another, and it shows that it allows the users to view whether there is a shift in going from one distribution to another. Now I'll talk about the another one, which is your scatter point plot. In the term of the scatter plot here, that this plot is used when there is a relationship pattern and or trend between the two numerical attribute, and in this that each pair of the values is treated as a pair of coordinates in an algebraic sense and plotted as points in the plane as well. So let's go ahead to discuss the last one, which is your Loess curve. In this, that adds a smooth curve to a scatter plot in order to provide a better perceptions of pattern of dependencies, and it is fitted by setting two parameters, and a smoothing parameter and a degree of the polynomial that are fitted by the regression as well. Let's go ahead with another one which we have to discuss, which is your what are the main purposes of statistical used in the data mining, and in the same cases that has also been played an important role as well. So let's go ahead to discuss about it. Which is known as main purposes of statistics used in data mining. The statistics used in the data mining, what are the main purposes of statistics? That has been asked for 5 marks. So the statistics deals with the quantifications, collections, analysis, interpretations, and drawing the conclusion from the data. The statistics is a science of collecting, organizing, and analyzing the presenting data. Data mining is an interdisciplinary field that draws in a computer science and the database, artificial intelligence, machine learning, graphical and visualization model as well. The statistics and the ensuring pattern recognition, graphical and the visualization model, where the DM that involves in the analysis of a large existing database in order to pattern and the relationships to the data, and the other finding unexpected, surprising, and useful as well. The statistics is used in data mining for computing the skills required to manage the data and its analysis, and the required to manage the data and analysis and the automations of the data analysis as well. Where the main areas where the statistical approach in a practice that is used in the data mining are: the first we have is the sizes of data, the second is the curves of dimensionality, the third is assessing uncertainty, automated analysis, algorithm for the data analysis in the statistics, visualization, scalability, sampling, modeling relationship, and model selections as well. So these work comes under that is the statistical approach, and their practices has been used here. Now in the next will be the next classes that will talk about it, that will deal with it. And first of all, it's a huge request from my side to all the viewers. Please go through the subscribe button and please like, share, and subscribe our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. In the terms of the unit 1, which we had covered up the data warehouse, which is the overview, definition, data warehousing components, building a data warehouse, warehouse to database, mapping a data warehouse, and multiprocessor architecture, difference between database system and a data warehouse, multidimensional database system and the data warehouse, multidimensional data models, data cubes, stars, snowflakes, and fact constellation concept, hierarchy, process architecture, three-tier architecture, data mining as well. Smarting as well. So in the unit 2, we had covered up the data warehouse process and technology, which is your warehouse strategies, warehouse management and support process, warehouse planning and implementation, hardware and operating system for the data warehousing, client server computing, model and data warehousing, parallel processors and the cluster system, distributed DBMS implementation, warehouse software, and as well as the warehouse schema, the design and the data extraction and cleanup and transformation tool, warehouse metadata as well. In unit 3, which is we had covered up that the data mining and reduction. Here in this we have to cover up the overview, motivations, definitions, and functionalities, data processing, form of the data pre-processing, data cleaning, missing values, noisy data, binding, clustering, regressions, and computer and human impressions, inspections as well, inconsistent data, data integrations and transformation, data reduction, data cube aggregation, dimensionality reductions, data compression, numerosity reduction, that is discretizations and the concept hierarchy, generalization, and the decision tree as well. In unit 4, which is your classification and clustering, there we have to discuss about classification, definition, data generalization, analytical characterization, and analysis of attribute relevance, mining class, that is your comparison, statistical measures in the large databases, statistical based algorithm, difference-based algorithm, decision tree-based algorithm, clustering, introduction, similarity and distance measure, hierarchical and a partitional algorithm, hierarchical clustering, Cure and chameleon, density-based method, DB-scan, optics, grid-based method, sting, click, model-based method, statistical approach, and association rule, introduction, large item sets, basic algorithm, parallel and distributed algorithm, and neural network approach as well. In unit 5, that we have to cover up in the next coming class, which is your data visualization, where we have to cover up the aggregation, historical information, query facility, OLAP functions and tools, OLAP servers, rollup, molap, OLAP, data mining, interfaces, security, backup and recovery, turning, data warehousing, testing data warehouse applications and the recent trends, types of warehousing, application, web mining, spatial mining, and a temporal mining as well. And we'll have to discuss about very short type of question that has been asked. So first of all, it's a huge request from my side to please go through the subscribe button and please like, share, and subscribe to our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.